line, and hey, here's how to draw it really fast. Do you remember the first torture I put you through? I would give you an X, and you'd have to find a Y. I'd give you another X, you'd have to find another Y. Remember how I made that table and we had to plug in these inputs, these X values, and pull out these Y's? And when we did that, we got ordered pairs, and we could make the dots and then play connect the dots. Okay, guess what we're doing now? Same thing. I mean, you have a good heads up on this. You know when they're not going to, sometimes they might be straight lines, but you know they might not be. And your heads up is pretty detailed. For example, in the last one, had I made you draw that one, it's a good idea. I'm going to make you draw that one. But if I made you draw that one, how many curves would you have had? It was a power of 4, the degree, so 4 minus 1, you would have had 3 curves. Okay. Big picture. Maybe I won't make you draw it. Let me look at it one more time. We'll play it safe. I didn't plan to make you draw that one. But you could. Just like before, and you would know what it would look like. So you do have that strength going for you now. Maybe it won't be a line. Why do I keep saying that? If you're graphing it by hand, why do I keep reminding you that it might not be a line? When you had lines, how many points were you required to have? Only 2. Good. That was so fast. Is it going to be fast now? No, you can't just do 2 and draw a straight line. This stuff's going to have curves. That's why the degree will help you, because you'll know if you drew enough. You'll know if you drew enough or if you have to pick more numbers because you're missing curves. We'll say most of these, the reason I'm not doing the first one even is most of these will be nice enough that you don't have to use tons and tons of points, but you'll still have to use some. I'm going to choose for the graphing, though, to use problems from your textbook because I know the author didn't try to torture you too bad. So let's look at page 363, and we'll look at some of the even problems. How about number 20? So in this one, we have a polynomial where x is the variable, p of x, is equal to 2x squared plus 3. Nice. Nicer if it looks prettier, but still nice. And we're being told, hey, graph this. Just like before, we can make a table, a nice, pretty data set to help us make our picture. It's true it's going to be a bit of a pain, and if I taught you how to use your calculator, you'd be my friend, but I'm not teaching you that yet. That's a shortcut that I'll teach you guys one day if we have time, okay? Or when you take the 0 to 80, the first thing you should ask your teacher is, could you please show me how to do this in my calculator? Because there's a really easy way to get this table from there, okay? I just don't want to spoil you too much when you should be learning the concept. So let's develop the concept together. Let's torture ourselves a bit. The idea is with most of these, if you look at the book, they give you a hint. What's the smallest x they have on these pictures? It doesn't go past an x of -5, does it, on the x-axis, side to side? And it doesn't get bigger than a +5. So guess what? It is true that in real life, if I gave you a crazy example, maybe you'd have to pick -100, -99, and do lots of x's starting with some big numbers, but guess what? We'll use little ones because we know the author was nice. Because he gave us pictures to draw on that only have -5 as the smallest. So I'm going to say, let's use -5, -4, -3. Remembering, of course, that you could use decimals if you like decimals and fractions. Who cares? I personally don't like those as much. And in fact, if you do your homework, guys, you're going to notice you don't even have to do this many points. I think the author just goes like out to 3 on both sides, or 2 on both sides, you know. So you'll start to notice what seems faster. Here's the torture. Do you see it happening? You want to split this up? I don't have time to do this for you guys. Why don't, who wants to do number -5? Here, I'll help you with the -5, then I'm making you guys do the rest. Okay. P, where x is -5, right? That's the first one right here. So we're going to plug in 2 with -5 for the x plus 3. Let's see, 2 times. Notice this example is different than the one we saw in review tonight, or when we wrapped up 6.1 tonight, because the -5 is in parentheses. The entire piece is being raised to the power of 2. Remember in the exponential section, what was that, like number, I don't remember, was it 67? Somewhere around there in the 6.1 section, we noticed that an exponent problem had the negative not in parentheses, and it's a big difference. Here we have parentheses, So we're saying negative 5 times negative 5 to get positive 25. Okay, 2 times 25, I'm getting a 50, plus a 3. What do I have here?
53.
Okay, 53, sounds good. Note that this top point, for example, negative 5, comma 53. Ooh, see, I'm so glad you guys wrote it so you can see what I'm going through up here. Negative 5, comma 53. That's an x and a y. You can put that on a graph on some table, right? That one could be a little big. Let's pick our favorite points here. Let me highlight some. I was just teasing you anyway, Paul. Okay, I'm gonna let's see. That's not what I want to do. I want to highlight this area. Let's just do between, I don't know, how about negative 2 to 2? Because that's pretty high. I think we'll get enough of the picture from that. If we don't, we'll do more points, okay? Because remember, we could have made points to like as big as we wanted, as small as we wanted. And I don't want to make my picture go up 53 steps high. So I'm going to attempt to be lazy. And we may have to add more points if we don't get the curves. Again, looking at this one, we have 2x squared. The degree is 2, 2 minus 1. How many curves do I need before I know I've been successful? 1. And what happens after your curves? The reason we can stop when you have the curve? Yeah, the lines will just shoot out one way or another. So the curve is the important part. That's the main part of the picture. And so as long as we can get one curve from these points, let's hope we do. Okay, so you guys, let's make our coordinate plane. Let's see, I'll use x and y. Let's see, negative 2, 11. 1, 2. Way up there for the first point, negative 1, 5. We'll go back 1, up 5. 1, 2, 3, 4, 5. So right there. Oh, man. Okay. 0, 3. 1, 5. 1, 2, 3, 4, 5. Did I make a mistake? I made a mistake, didn't I? Oh, no. Hopefully you guys are better at graphing than me. Okay, that's the first point. I made a mess with the second point. Negative 2, 11. And then we have negative 1, 5. So negative 1, up 5, 1, 2, 3, 4, 5. I meant to put that there, and I put it on the axis. That would have been not right. 0, 3. So we go side to side, none, up 3, 1, 2, 3. Then we have 1, 5, 1, 1, 2, 3, 4, 5. 2, 11. And then guess what you get to do? You play connect the dots. Let me show you. You kind of do what's reasonable in order. You know, you go left to right and connect them like that. So you knew from the far left when you go to the very next one over, because you read it like a book, left to right, when you're graphing these functions and connecting the dots. Did we get our one curve? Sure. So we know we've gotten the most significant stuff on the picture, even though we didn't use all the points. And we could have made more points. If I didn't see the curve, I'd just add points to my table. Who cares? I'd probably be kind of smart and pick the direction where I was missing part of the picture. If I saw a curve starting on one end, I'd probably start adding to my x's there to see if I could finish my picture. But that's it. That's all they want you to do when they say graph polynomials. Pretty cool, huh? In the homework, I would use between negative 3 and 3 or negative 2 to 2. You can never pick too many. The worst case is if you don't pick enough, you just have to pick more. So what I would do, see the ones I highlighted, I would use those in your homework. Yes, I would keep them balanced because just by looking at the examples in the book, they're having a lot of them happen kind of in the middle of the picture. So balancing how, you know, going the same amount in the negatives to the same amount in the positives will be kind of helpful. And when you're doing this, some of these will have curves and things. Be really careful with how you plug in for your table, okay? In fact, let me do one with a cubed on it. Well, How about this? Look on page 360 because I want you guys to have lab time to work. On page 360 in your textbook, do you see how they have a table where they've made some points? They used -2 to 2. They found those y values, so they made a table. And then see how they graphed the picture and it had curves on it? Now they knew it would have 2 curves. So when they graphed it, let me at least write the table and I'll